Welcome, students of pre-calculus, to another lesson in our unit on trig and the unit circle. In today's lesson, we are going to extend a little bit of the knowledge that we covered in the previous lesson into different types of angle measures. So in today's lesson, we're going to be going into angle measures that are greater than 360, greater than 2 pi radians, which we've done before. But at the same time, we'll also be looking at negative angle and radian measures as well. So let's get to it. The first thing that we're going to do is we're going to complete, and hopefully you have your full circle in front of you that you copied down in a previous lesson with all the points A, B, C, D, E, F, G, H, I, J, K, L. We're going to quickly finish up all the angle measurements for each of the points. So we already talked about the angle measurements for A, B, and C. Okay, so just a quick recap there. A represented a radian measure of pi over 6 radians, or 30 degrees. B represented corresponded to a radian measure of pi over 4 radians, or 45 degrees. And then C was pi over 3 radians, or 60 degrees. Whoops, I don't know why I put 30 degrees, 60 degrees. So let's continue going around. And, well, I technically missed one. Our starting point, 1, 0, is, hopefully it's obvious that that's just 0 degrees, because that's where we start. Okay, so let's continue on. Now, the point 0, 1, so the top edge of the circle, the point 0, 1, that would correspond to pi over 2 radians, or 45 degrees. Okay, so pi over 2 radians, or 45 degrees. Point D would correspond to 2 pi over 3 radians, or 120 degrees, which hopefully makes sense. It's just going to be double point C, since point C is 1 pi over 3 radians, point D is 2 pi, so 120 degrees. Point E is going to be 3 pi over 4, or 135 degrees. Point F is going to be, can I zoom in more? Yeah, there we go. Point F is going to be 5 pi over 6 radians, or 150 degrees. So can I make this a little bit? No, I can't. Now we move on to negative 1, 0, the point negative 1, 0. That's going to be pi radians, because it's half a circle. And we know half a circle is 180 degrees. Continuing on, point G will be 7 pi over 6, or 210 degrees. Point H will be 5 pi over 4 radians, or 225 degrees. Point I is going to be, I had to think there for a second, 4 pi over 3 radians, or 240 degrees. The point at the bottom there, 0, 1, would correspond to 3 pi over 2 radians, or 270 degrees. So it's 3/4 of the way, in other words, 270 degrees. Point J is going to be 5 pi over 3 radians, or 300 degrees. Point K is going to be 7 pi over 4 radians, or 315 degrees. And then finally, point L is going to be 11 pi over 6 radians, or 330 degrees. And then, obviously, if we do a full circle, that's going to be 2 pi radians, or 360 degrees. And obviously, a full circle is going to be the same point as 0 degrees, because where you start is also where you end if you do a full circle around. So make sure you write down all those radian and angle and degree measures for each of those points, because remember, we reference those when we actually look at our unit circle. Okay. Before today, we had only done the first quadrant of measures, but here are the other 13? No, 12 of them. So make sure you have those written down in addition to those coordinate points that hopefully you have written down for each of the points as well. Okay, so now that we have all that written down, so obviously you can just pause the video and make sure you have them all written down. Let's evaluate a few more of these trig values using the unit circle. Okay, so this hopefully should be, especially after the bell ringer and our previous lesson, hopefully this should be relatively a little bit more automatic than previously. So we know that the sine of an angle is just equal to the y value of the point on the unit circle. Okay, so for the first one, we're looking up 120 degrees. All right, so we look at our unit circle, 120 degrees. So 120 degrees would be point D. Okay, so once again, hopefully you have written down the point. The point at point D is -1/2 comma radical 3 over 2. But once again, hopefully you have that written down already. So we're just looking at the y value this time around since we're looking at sine, just the y value of the point. So that means our answer for that first one is radical 3 over 2. Okay? So point D, radical 3 over 2. So now let's look at part B. So part B is cosine of pi. Okay, so now let's look back at our unit circle. And just a reminder, cosine of an angle is equal to the x value of the point on the unit circle. So let's look at pi radians. So pi radians is all the way over here at -1 comma 0. So it's on the left edge of the circle, -1 comma 0. So since we're looking for cosine, we are looking at just the x value of that point, which is -1, which means our final answer for cosine of pi radians is just -1. So that would be -1 comma 0. That's the point that we're looking at. Then finally, tangent of 210 degrees. Recall that tangent is equal to y over x. So the y value of the point on the unit circle divided by the x value of the point on the unit circle. So let's look up 210 degrees. So 210 degrees looks to be point G. And hopefully, like I said, hopefully you have this written down on your circle already. The coordinates of that point G are negative radical 3 over 2, comma -1/2. So we're going to take the y value divided by the x value. Okay, so the y value is -1/2, the x value is negative radical 3 over 2. So let's do that. So -1/2 over negative radical 3 over 2. Now we could leave it that way, but for the purposes of this exercise, let's actually simplify it. So remember that whenever you're dividing by a fraction, that is equivalent to multiplying by the reciprocal of that fraction. So the reciprocal of radical 3 over 2 is just 2 over radical 3. So you just flip the fraction. So now if we multiply this out, we end up with positive, since you're multiplying two negatives, positive 2 over 2 radical 3. So the two 2's actually cancel out, and all we're left with is 1 over radical 3 as our final answer. Now we can take this even a step further. Remember, if we want to get rid of a square root on the bottom, whenever you want to get rid of a square root on the bottom, you multiply by that square root. So square root of 3 over square root of 3, the top and the bottom. So that gives us square root of 3 over square root of 9, because 3 times 3 is 9. And the square root of 9 is just 3. So if we went all the way with our simplifying, that would be our final answer, square root of 3 over 3. Okay. All right. So there you go. Quick review of basically the previous lesson, except this time we're just looking at different angle measures. So for the next three parts, D, E, and F, that should not say C, that should say F, D, E, and F, I want you to do these three on your own. Okay, so once again, as long as you have the circle in front of you, You just have to look up the points and put the appropriate x or y value depending on if it's sine, cosine, and tangent. Okay, so these three I would like for you to do on your own. All right, let's get to something new. Well, kind of new, kind of not. And this is looking past 360 degree or 2 pi radians. Now, this is something we've done before. Back when we were locating points on the unit circle, we got to this idea of, well, what if the radian measure is greater than 2 pi? Okay, what if the radian measure is greater than 2 pi? And remember the strategy that we used. Okay, the strategy that we used is we simplified the fraction. So let's take this first one, 9 pi over 4. So 9 pi over 4, if we divide it out, so how many times does 4 go into 9? How many times does 4 go into 9? 4 goes into 9 2 times. So that's 2 pi, and 1 is left over. Okay, so 4 goes into 9 2 times, and 1 is left over. So that means this is equal to 2 pi with 1 pi over 4 left over. Well, remember, 2 pi is just a full circle. Okay? 2 pi is just a full circle. So you go a full circle around, and now you're just at the starting point, right? You go a full circle around, and now you're just at the starting point. And then we're told to go an extra pi over 4. So if we go an extra pi over 4, well, that means we're at point B, because that's an extra pi over 4. So, we did that one. So that means for this problem, you should be looking at point B as your reference. Okay, point B as your reference. So in this case, since it's sine, we're looking for the y value. So for the y value at point B, it is radical 2 over 2. Okay, so we've used that strategy before when trying to determine where it is when it's greater than 2 pi. Okay, so for part B, just try that one out on your own. Okay, so for part B, do that one out on your own using that same strategy. Now for part C, on the other hand, we've never really looked at angle measures greater than 360. Never really looked at angle measures greater than 360, but hopefully it shouldn't be anywhere near as hard. If anything, hopefully it should be easier. And the reason why I say that is just because it's a little bit easier to deal with degree measures as opposed to looking at all those pi radians. So once again, this is greater than 360. So we know it's going to be a full circle. So let's do this. We know a full circle is 360, okay? So let's say we've traveled 360 degrees around, okay? So let's see how much do we have left. How much do we have left if we've done 360 degrees already? Well, if we've done 360 degrees already, we have 630 degrees left. So that means we can do another full circle. Let's do another full circle. How much do we have left now? It looks like we have left 270 degrees. Okay, so we've done 2 full circles. Okay, so full circle, and then this is what we have remaining. Okay, so if we look back at our unit circle, so let me erase this. So 1 full circle, 2 full circles, and then we have remaining 270 degrees. So remaining 270 degrees, boom. Okay, so it looks like we end up at that 0, -1 point. Okay, so that's 0, -1 point. So in this case, since tangent is y over x, we're going to end up with y, which is -1, over x, which is 0. Uh-oh, we have division by 0. Undefined. Whenever you divide by 0, you get an undefined answer. So that's your final answer for part C. So once again, part B, do on your own. So nothing necessarily new here. It's just we're, going a little bit an extra step in terms of just evaluating the trig functions after determining which point we're at. So at -1, 0, -1. All right. So now let's look at something that is new. We've never looked at these kinds of angle measures before, and we're talking about here negative angle measures. So what does that mean? What are negative angle measures, or how do they work? So negative angle measures, the way negative angle measures work is that they simply go in the opposite direction. So instead of moving counterclockwise around your circle, right, we would always draw two circles here. We would always move counterclockwise around our circle. When you have negative angle measures, you're going to be moving clockwise around your circle. Okay? So clockwise around your circle. So I'm going to be showing a few different ways in order for you to arrive at the correct point on the unit circle. A few different ways to think about it. All right, so let's look at these. So evaluate each of the trig functions using the unit circle. So the first one, cosine of negative 5 pi over 4. So cosine of negative 5 pi over 4. Okay. So here's one way. So method 1. Method 1 is try to think of where 5 pi over 4 is on the unit circle. Okay. Let's try method 1. So where is 5 pi, so positive 5 pi over 4, where is positive 5 pi over 4 on the circle, on the unit circle? Okay, so you would look it up. You would look up where 5 pi over 4 on the unit circle is, positive 5 pi over 4, and hopefully you would see it is point, let's see, A, B, C, D, E, F. It would be point H. Okay, it would be point H on the unit circle. So if you looked it up on the circle, you would find it at point H. Now, here's the trick. In order to determine where negative 5 pi over 4 is, now go to the opposite side of the x-axis. Okay, so go to the same spot on the circle, but just on the opposite side of the x-axis. Well, where do you end up at? You end up at point, let's see, ABC, point E. So that is where your negative angle measure is. That is where your negative angle measure is. So point E in this case. Okay, so in this case, since it's cosine, it means our final answer is, let's see, negative radical 2 over 2. Okay, so let me just quickly show you what that would look like on the circle. So if we go back here, so, let me erase all this stuff here. Okay, so 5 pi over 4 is point H, right? 5 pi over 4 is point H, which we can see here in the bottom left. Okay, come on. Oh, doesn't let me zoom in. Okay, so once again, we're going on the opposite side of the x-axis. So the opposite side of the x-axis would be here, the x-axis, not the y-axis. So since we're looking for the negative one, that would correspond to point E. Okay, that would correspond to point E. And then we just look up the x value since we're looking for cosine. Okay, so that's one way to do it. Okay, so find the positive version first, and then just go to the other side of the x-axis, and you get your point for the negative variation. So that's method 1. Okay, that's method 1. Oh, no. Sorry about that. So now let's talk about another method. Okay, let's talk about another method. Another method is trying to think of it as going the same distance around the circle. Okay? So measure the positive distance around, then go the same distance in the other direction. Okay, so that's method 2. So for this one, I think I'm just draw a circle on here. Okay, so here's your unit circle. So let's do positive 3 pi over 2. Positive 3 pi over 2. So if you look at our unit circle, if you go positive 3 pi over 2, you should end up there. Okay, positive 3 pi over 2. So if you look up 3 pi over 2 radians on your unit circle, you'll see it's in the bottom edge of the circle. Okay, so you'll see that's the distance we traveled around. Well, now let's travel the same distance, but in the opposite direction. Okay, let's travel the same distance, but in the opposite direction. So in this case, it would be, so the opposite direction, so clockwise. So the same distance, but in the opposite direction would bring us there. Okay, would bring us there. So that's the same distance, just in the opposite direction. Okay, and typically the technique that I encourage students to use to help them a little bit with measuring the distance is just count the number of points that you went around the circle. So literally just count the points. So like 1, 2, 3, 4, 5, 6, 7. So I went 7 in this direction, so I should go 7 in the other direction to get to the same point. So that's method 2. So in this case, you would be, because we're going in the negative direction, so in the opposite direction, you would be at the top edge of the circle. The top edge of the circle. So that would correspond to the point, what is that, 0, 1. So since we're talking about the y value, that means our final answer is just 1 for sine. Okay, so that's another method. Now let me show you method 3. Okay, if you didn't like those first 2 methods, let me show you method 3. So method 3 is you add 2 pi or 360, so 2 pi radians or 360, until your answer is positive. So add 2 pi or 360 to your negative angle measure until it is positive. So in this case, we have negative 60 degrees. Okay, so let's add 360 to it. Okay, let's add 360. So add 360 degrees or 2 pi. Obviously, you add 360 if it's in degrees. You add 2 pi if it's in radians. Or 2 pi until positive. Okay. So let's do negative 60 degrees plus 360 degrees, and that is positive 300 degrees. Well, positive 300 degrees, we know where that is on the unit circle, right? If you look it up on the unit circle, points, A, B, C, D, E, F, G, H, I, point J, okay? Point J would represent 300 degrees. If you just look up 300 degrees on the unit circle, you would see that it is point J. Okay, and the reason why method 3 works, is just think about it. If you add 360 degrees, all you're doing is you're ending up in the exact same spot since you're going a full circle around. And the same thing goes with 2 pi. So that's why this method of adding 360 degrees works, because you end up in the exact same place you started, except now you have a positive measure. So if we look up point J, so let's see, point J would be down there. So the y value, okay. So in this case, it would be negative radical 3 over 2 over positive 1/2, because the x value would be. So if we were to quickly simplify that, we'd end up with negative radical 3 over 2 times the reciprocal of 1/2, so 2 over 1. So negative radical 3, negative 2 radical 3 over 2. 2's cancel out. We're left with negative radical 3. Okay, so those are 3 methods in which you can think of the negative angle measures. 3 different methods. Hopefully you like one of them. Hopefully one of them makes sense to you. All right, so let's talk about one last thing, and we're going to revisit cosecant, secant, and cotangent. Okay, we're revisiting cosecant, secant, and cotangent. So if you remember these 3 functions, these are the reciprocal functions. Okay, these are the reciprocal functions. Okay, and they're called the reciprocal functions because each of them are a reciprocal of the other three trig functions. So cosecant, if you recall, is the reciprocal of sine. So another way to think of cosecant, okay, in the past we did hypotenuse over opposite. Another way to think of cosecant, since it is the reciprocal of sine, is 1 over the sine of theta. That is literally the reciprocal of sine. Or a relationship we established earlier when it comes to the unit circle is that since sine is y, we can just rewrite this as 1 over y, right? We know sine is equal to the y value of your point on the unit circle, so just replace the sine with a y. And then we can do the same thing with secant. Secant is the reciprocal of cosine, and we know cosine is equal to what? It's equal to the x value of the point on the unit circle. And then finally cotangent. Cotangent is equal to the reciprocal of tangent, and we know tangent is equal to y over x. So we just replace the tangent with y over x. And we can actually rewrite this a little bit differently. Since it's the reciprocal, x over y. We literally just flip the fraction, so x over y. So that's cotangent. Okay, so these are three new relationships you can think about when it comes to cosecant, secant, and cotangent and relating them to the points on the unit circle. So if we look at a quick example here, example 4. So cosecant of pi over 4. Cosecant of pi over 4. So we just said cosecant is the reciprocal of sine, and since sine is y, it just become 1 over y. So if we look up pi over 4 on our unit circle, that would be point B. Okay, so if you look up pi over 4 radians on your unit circle, that would be point B. So point B, we're looking at just the y value. So 1 over the square root of 2 over 2. So now we can take the reciprocal of it, right? Because you're dividing by a fraction. So it becomes 2 over radical 2. 2 over radical 2. And we could leave it that way, or we can go through the whole process of getting rid of the square root in the denominator. So square root of 4, 2 square root of 2 over 2. 2's cancel out. All you're left with is square root of 2. Okay? Secant, I'm going to have you do on your own. Okay, secant, I'm going to have you do on your own. And then cotangent, we'll quickly do cotangent. Uh-oh, we have a negative angle measure here. So let's quickly do that one. Okay, we have a negative angle measure here. So remember, you can use any of the three methods. Okay, I'm going to use, for this one, let's see. Yeah, I'm going to do method 1. Okay, for this one, I'm going to do method 1. So I'm going to locate on the unit circle positive pi over 3. So positive pi over 3 would be, if you look on your unit circle, point C. Okay, so positive pi over 3 on the unit circle will be point C. But since we have negative pi over 3 here, we're going to go on the opposite side of the x-axis. So that would be, let's see, man, I have to try to do this from my head. So A, B, C, D, E, F, G, H, I. That would be point J, okay? So you should be looking at point J if you're looking on the opposite side of the x-axis. So now we're looking for cotangent x over y. Okay, we're looking at x over y. So in this case, let's see. So the x value would be 1/2. And the y value would be negative radical 3 over 2. So remember, whenever you divide by a fraction, you multiply by the reciprocal. So let's see what we got here. So we got negative 2 over 2 radical 3. 2's cancel out, and you're left with negative 1 radical 3, which once again, we can get rid of the square root in the denominator by multiplying by itself, the top and the bottom. Don't forget the top and the bottom. So negative radical 3 over radical 9. So negative radical 3 over 3. So there you go. those are your new concepts for today's lesson. So just a quick recap. We talked about, we revisited going past 360 degrees or more than 2 pi radians. I did introduce you to the negative angle measure, so remember going in the opposite direction, clockwise instead of counterclockwise. And then finally we talked about this idea of new definitions for cosecant, secant, and cotangent respectively. As usual, make sure, in addition to the notes that you'll be submitting, make sure you also turn in the on your own problems. There weren't that many this time. I think there were only 5 on your own problems. So hopefully you can use some of the strategies discussed in order to arrive at your answers. Once again, make sure you have this completed unit circle written down in your notes, people. You will be referencing it a lot. You will be using it on future quizzes and tests. So you will definitely need it. Otherwise, let me know if any questions pop up, obviously. I hope this lesson went smoothly. I hope you guys stay safe.